Take an everyday grape, cut it neatly in half, and place it inside a microwave. Within seconds, it erupts into a brilliant glowing spark. While it looks like the fruit is simply burning, the effect has nothing to do with the grape's sugar content or standard combustion. This flash marks the sudden, violent creation of plasma, the highly energetic fourth state of matter. This is the same material that churns inside the massive core of a star. On Earth, plasma usually appears during high-energy weather events, like when a lightning bolt strikes a skyscraper. Because of that raw energy, you should never try this yourself. Even a spark this small is powerful enough to melt internal components and start a fire. This raises a difficult question. How does a household box built to warm up leftovers manage to summon the same cosmic fire as the sun? Inside every microwave sits a metal component called a magnetron. When turned on, it floods the inner chamber with invisible energy waves. These waves bypass the ceramic plate and the surrounding air. Instead, they specifically target and are absorbed by water molecules. When those water molecules absorb the microwave energy, they begin to violently vibrate and spin. All that rapid friction causes the temperature to spike. But a potato is full of water and doesn't spark. The difference lies in the fact that a grape acts as a microwave resonator. Because of its specific size and shape, a grape forces incoming microwaves to bend. Much like a magnifying glass focusing sunlight, it traps those waves and forces them to converge tightly into an intensely hot center. To a microwave, the grape functions as a precise geometric trap, forcing invisible energy waves to concentrate rather than pass through the fruit. A single grape on its own won't spark. The reaction requires two halves placed so they are nearly touching. When two of these resonators sit side by side, the wave energy trapped inside both of them is forced to pile up directly into the microscopic gap between them. Like restricting a garden hose with your thumb, the grape halves squeeze the electric field, drastically increasing its pressure. This instantly boils the surface water, releasing a plume of steam. Inside this steam, the intense field physically rips electrons away from their atoms. Those freed electrons immediately smash into neighboring atoms, knocking loose even more electrons. In a fraction of a second, you trigger a runaway subatomic collision. This electrically charged gas is plasma. As those highly energized atoms settle back to their normal state, they release their excess energy as a brilliant flash of visible light. This glowing cloud is a self-sustaining subatomic avalanche born from the compression of microwave energy. Researchers long assumed the grape's thin bridge of skin acted like a wire to conduct electricity. Recent experiments prove the skin is irrelevant. The entire phenomenon relies on having two water-rich spheres of a specific size to trap and concentrate waves. This principle of wave concentration is the foundation of advanced modern engineering. By understanding how geometry traps and amplifies waves, engineers built radar networks that guide global aviation. The same physics dictates how we compress light into highly focused beams for manufacturing and laser surgeries. We use these wave-trapping properties to fire digital data through microscopic glass threads, powering the internet. The physical laws governing our most advanced technologies manifest in your kitchen, requiring nothing more than specific geometry to reveal the mechanics of the cosmos.